Sempala Harrison, coming from Group 9, whereby we are Sempala Harrison, Nalugo Linda, Shenaz Adam Ibrahim, Joel Agaba Muhanguzi, and we are here to present the fire detection system. Fires in Uganda and the world at large have been rampant over the years, and because of this, many people have lost their lives, many have lost their properties, many have been displaced, and let alone those that have lost their family members. Children have become homeless, parents have become childless, and the sequence flows. But with our project and our application here, we are seeing to end this. We have come to an end of this project, of this time, of this era. We are detecting fires using detectors that detect the current amount of carbon dioxide in the atmosphere, which alerts the system administrators, which call upon the authorities to come and check if there's any problem. By doing so, we are controlling the home incidents, we are controlling the industrial incidents, we are controlling the wildfires that rampantly happen. As a case study, we are having Ginger for Uganda, whereby in Ginger for the past years, we have been having fires and people have lost many of their goods. But what can they do? What have they done? Nothing, until we saw to it that we can change this. People have been calling and reaching out to these fire department people, but they have been reaching late. But with this system, we detect the issue and send a message to them, calling them hurriedly before even the system becomes too harsh. We detect the amount of carbon dioxide in the air, check it, and examine if it's really below or above the alerting state. With this, we call upon the authorities who later in time come to solve the issue. Thank you.
So in this case, I'm going to talk about the system overview and the features. In this case, I'll talk about the home page of the admin panel. So it contains the navigation bar. This helps us to access the different sections like the alerts, the sensor data, about, area alerts. So in this case, we shall make use of the Django administration. So it includes the sensor data. So in this case, we don't have the actual real-time sensor data, so we shall make use of the test inputs. So it contains the list of the data that is fed into the system. So via the add, we shall keep adding and editing the data. So for instance, you can use 4500. I'll save and continue editing. So this will be successfully added to my list. So to check, so 4500 will be included into our data. So back to our home page. So this contains the profile, and in the profile there is the name, status, post, email, contact, year of the years you've taken, the rank. So this is all connected to the person, the concerned authorities. So under the navigation bars, I also have the sensor data. So the sensor data contains the time, the date which the alert happened. Also, our data was structured in a way that above 1,000, the alert is verified, and below 1,000, the alert is considered to be in a safe state. So those in the red are the verified ones above 1,000. Then those in the green are those considered in a safe state. So they are inactive, in other words. So I'll have the level, the time, the date, all under the sensor data. So under the about, so for this case, it talks more about our fire detection system, our project purpose, our key features, our technologies used, and also our team members. So I also have the area alerts, those areas that have faced the issues, the fire and smoke. So the areas that have been greatly affected will be listed under this part. But in this case, we have no alerts present at the moment. So we shall discover them in the due course.
Yes, so I'm going to explain the technical aspect of our program, and starting plainly from how the front end looks like, going to the back end of the Django administration. So just like my colleague talked about how we're using superficial data, and these are the results we're using for this project. She explained how we use the add function, that's right here, to add values that don't exist, but these values correspond to what we base on to give meaningful results. So this is our database, and we set a criteria as to which values are taken as a fire occurring and which values are not, basing on how much carbon dioxide is being detected in the environment. So from then on, we linked our Django back end to our front end, which gives us these data results, where whichever data item we fill into the Django back end is mirrored here. And it's automatically given a green or red stamp to signify if it's safe or if it's an alert. So yes. So after here, for us to make this project run, we had to create a virtual environment for our own practice, a main folder, which is the fire and detection folder, and then the my site folder, which has the dependencies that our front end uses to display all the variables that we need. So when we come here, when we open the main fire and smoke detection folder, we have our modules, we have our views and our URLs. All these are the back-end dependencies, as we can see from here. Then our modules, if I open the code, shows those files that contain the Python backend for the sensor data, the alert data, the user profiles, and how they're going to operate. So I can give you a brief view of how that looks like. So it's not that impressive, but yeah. We have our precautions set and we have our libraries called upon. And from that, we can tell that we have subjects in here, such as the CO2 alert system and when they are detected, what happens. And then one of the main important aspects of this program is that in terms of its functioning, when an alert is triggered by a sensor, it causes the system to send a back-end message via an email to the emergency service email. We do this to emulate the system where, the real-world system where instead of just it warning what happens, it will call the emergency service center. But we've just represented that using emails right here. So, as you can see in our code, we give off a precaution, sorry, an area where we can give a sample email, as you can see on line 38 of the program. So if that's filled and the criteria for an alert is fulfilled, this will trigger the system to send the email. Yeah, so after that, we have the views, which are the dependencies for the front end. Then afterwards, we go to the templates, which is where our actual front end is, which has the main areas for the HTML and the CSS. Yes, I've explained a bit of the static file, which has things like the images we have in our website, such as our logo and the individual that's on the profile. Once all this is satisfied, so as I was saying, we use the files in the static folder, such as the Facebook, Instagram, WhatsApp, PNGs to show our social media handles at the bottom. Same to the logo PNG and the profile PNG that we are going to use into our system. And all of that wraps up to create a bootstrapped interactive website stroke platform. And yeah, everything else. These data files are not the ones that we're actually going to use in real life, except the fact that we're going to have to use sensor data. But these are projected values, sample values of our space, and everything else works out. And our alerts are separated, and all these alerts are going to send an email, such as the one I showed you in the model Python file. They will send an email to the fire and safety system email. The about also ties up to make a full working program.
For the pitch and the future work, we thought of increasing our scale, because now our case study is Ginger, but with later times we feel the whole world should share with us this goal. We want to extend it to the cities like Mbale, Kampala, and throughout East Africa. We want to move to a worldwide deployment of what we have done. Furthermore, we want to integrate it with emergency services. More than the email, we want to put numbers, phone numbers, that in case of any problem that happens, the officials are called at the instant. And with this, our people are being saved. And this alone saves not only lives, but also time. We are planning on adding mobile applications so that each and everyone in the country can share with us this app, and data can easily be moved from within one person to another using this app. Having the app will have shared data, availability of people, and even furthermore things that will come along the way. And as our final adjustment that we'll be having in the future is adding machine learning. With machine learning, we want to implement and predict analytics using forecasting tools and measures, whereby we can tell that because of such weather, we can get wildfires. Because of something can happen. And with this, our system can be called finished. But all this will be possible by your help after testing this with us and seeing how good it will come about. Thank you.